Welcome to this note. Today we're stepping into what's essentially a premium mentorship session on the invisible laws that power trillion-dollar digital economies. And more importantly, we're going to look at how you can leverage them to build, scale, and actually monetize your own business. Think of this as your global masterclass in digital architecture. We aren't just going to learn what the internet is, We're going to understand the exact underlying mechanisms that allow modern startups, AI platforms, and massive e-commerce empires to truly thrive.
Okay, let's dive right in. I really want you to ask yourself, what unseen laws of physics govern everything you do online? Whether you're integrating a brand new AI API, scaling up a SaaS platform, or launching a massive e-commerce storefront, there is this hidden layer of rules totally dictating your success. Literally every time you send a message, stream a video, or process a payment, you're relying on a remarkably complex, perfectly orchestrated system of agreements. And honestly, understanding these rules is exactly what separates the everyday users of the internet from the actual architects of the digital economy.
So, here's our syllabus for today. First, we'll cover the internet's invisible laws. Second, the TCP/IP layered machine. Third, transport, TCP versus UDP. Fourth, HTTP3 and the quick era. And finally, number 5, routing the global economy.
Let's kick things off with Section 1, the Internet's Invisible Laws. So the absolute crucial starting point here is understanding what a protocol actually is. Well, simply put, a protocol is just a formal communication agreement between two or more systems. It defines exactly how data is formatted, how it's transmitted, and how errors are handled along the way. Imagine if every single computer, smartphone, and server out there spoke a completely different invented language. The internet would be absolute chaos, right? Computers differ so wildly in their hardware, their software, their architecture. Protocols act as the ultimate universal translator. They ensure compatibility, security, and efficiency. They are the exact reason a message sent from an iPhone in Tokyo can be instantly read on a Windows PC in London.
To really anchor this, think about the historical context we're dealing with here. Consider the printing press or the early telephone. The internet isn't some kind of magic. It's simply the ultimate, high-speed evolution of these historical communication tools. Just as the printing press scaled the distribution of human knowledge, and the telephone scaled real-time connection, internet protocols scale global business and data exchange literally at the speed of light. Mastering this stuff, it gives you the exact same leverage early industrialists had during the Industrial Revolution.
Moving right along to Section 2, the TCP/IP layered machine. So the sheer complexity of the internet actually breaks down into 4 highly structured, logical layers. It's like a giant puzzle. At the very top, we've got the application layer. This is where your software lives. HTTP for your websites, DNS for domain names. Right beneath that is the transport layer, where TCP and UDP decide exactly how your data will be reliably or speedily delivered. Then comes the internet layer, which uses IP addresses to route your packets globally. And finally, right at the bottom, the network access layer translates all of this into physical reality, the actual Wi-Fi signals and fiber optic cables. Now, when you build a software business, you're mostly playing up in that top layer, sure, but your success depends entirely on the 3 layers beneath it. And all of this infrastructure builds on a really fascinating piece of history. Back in September 1981, the Defense Advanced Research Projects Agency, DARPA, published RFC 793. This was just a simple, typewritten government paper that officially defined the transmission control protocol. It is absolutely incredible to think that this specific, humble document laid the exact foundation for the digital economy that today powers multi-billion-dollar startups, cloud computing, and massive streams of global digital income.
All right, Section 3, Transport, TCP versus UDP. Okay, let's really dive into this comparison because it is vital. On one side of the ring, we have TCP. TCP is all about absolute reliability. It uses this very formal 3-way handshake to establish a highly secure connection, and it totally guarantees that your data arrives flawlessly and in the correct order. If a packet gets lost, TCP stops right there and resends it. Now, on the other side, we've got UDP. UDP is a connectionless, fire-and-forget kind of protocol. It doesn't check for errors, and honestly, it doesn't care at all if a packet gets dropped. It just blasts the data out as fast as physically possible. And you know what? This choice matters entirely for your bottom line. If you're building a B2B SaaS platform, an e-commerce checkout, or some kind of financial app, you absolutely must use TCP. You just cannot afford to lose a single packet of data during a credit card transaction. Your monetization completely depends on secure, guaranteed data integrity. But if you're building the next great live streaming platform, a VoIP application, or a real-time multiplayer game,
You want UDP for sure. In those types of businesses, a drop frame of video is totally fine, but latency will completely kill your user retention. Choosing the right protocol directly impacts your product's performance and ultimately your revenue.
Next up, Section 4, HTTP3 and the quick era.
34%. I mean, that is just a massive number. Currently, over 34% of top websites, including absolute industry giants like YouTube, Instagram, Amazon, and WordPress, have already adopted HTTP/3. So this isn't just some experimental early adopter phase anymore. This is massive, proven industry demand. The biggest players in the world are aggressively upgrading their infrastructure right now because the performance gains are simply too substantial to ignore.
So what's driving this? Well, it's the QUIC protocol. What QUIC ingeniously does is take that blistering speed of UDP we just talked about, and it basically builds its own custom reliability and encryption right on top of it. It's brilliant. It enables zero round-trip time handshakes, which means returning users connect literally instantly. It also solves that old TCP issue known as head-of-line blocking, where one single lost packet awkwardly held up the whole line. Plus, it mandates state-of-the-art TLS 1.3 encryption by default. For digital business, this translates to dramatically lower latency, noticeably faster page loads, and way higher e-commerce conversion rates. It's a real game changer.
Which brings us to our final part, Section 5, Routing the Global Economy.
To understand how all this data gets where it needs to go, enter BGP, or Border Gateway Protocol. Honestly, you can just think of BGP as the critical postal service of the internet. The internet is basically made up of thousands of these large, distinct networks called autonomous systems. Think big cloud providers and major telecom companies. BGP is the exact protocol that allows these massive networks to actually talk to each other and constantly, dynamically calculate the absolute fastest, most efficient route for your data to travel, say, from a server in Singapore to a smartphone in New York. Without BGP, cross-border digital transactions would literally grind to a halt. So, when we zoom out and put it all together, we get the ultimate full-stack execution. Whenever you, or more importantly your customers, load a web app, this exact sequence happens in mere milliseconds. First, DNS translates the domain name into an IP address. Second, BGP routes that request across the global internet backbone. Third, TCP or QUIC steps in to establish a reliable transport connection. Fourth, TLS locks the whole thing down with military-grade encryption. And finally, HTTP delivers the actual application content right to the screen. Having a complete system-level understanding of this workflow, that is an absolute superpower for any founder, developer, or digital architect today.
Which brings us to the end of this note, and honestly, to a really important question. You now understand the deep, structural laws of the digital universe. You know the exact difference between the bulletproof reliability of TCP and the raw speed of UDP. You understand the future-ready power of QUIC and the global routing magic of BGP. The internet is no longer just a mystery. It's a perfectly logical system that's just waiting for you to utilize it. So the question is, how will you use these invisible laws to build the next great digital business? The playbook is yours. Now go build.